Hello, dear student. So, this is Dr. Hira, and today we will talk about another type of chemical bonding that is coordinate covalent bond. So, before this, we have discussed the what is the ionic bond and what are the covalent bonds and how they form. So, I hope you got that idea, and now that will be easier to establish another concept that is the coordinate covalent bonds. So, firstly, we will go for its definition. How could you define that? What is the coordinate covalent bond? So, this is a type of covalent bond in which one of the atoms provided both of the electrons in a shared pair. It is also known as dative covalent bond. So, these both terminologies are alternative. So, either you can use a coordinate covalent bond. And if you write the dative covalent bond, even then that is perfectly fine. But you should know that what this definition states. So what do we mean that the electron pair is shared by only one of the atoms which are paired? So I will explain you with an example. So, what are the different causes and how that bond formed is? Obviously, the first straight thing is that every atom is looking and it is in an urge to complete its octet one. But what is the case if an atom don't have sufficient neighbors or the atoms which can make the bond with that one? So this means that it has to look for something else to complete its octet one. So, for example, if there is a carbon and that or any of the atom, if they are only making the two bond with oxygen and the carbon is still not making enough bond that it can complete its octet one. So, what would be that bonding and how that form? So obviously, a molecule has to be in the most stable form. So then there will be another kind of bond will be formed, which is somehow different than the ionic and the covalent bond in terms that there is no complete sharing of one electron, and uh, it is also not the case that both of the atoms are contributing electron to make a bond. So what is that kind of chemical bonding is? So let's see. This is a carbon, and we know very well that the carbon is tetravalent. Tetravalent means it has the four unpaired electrons, and if it can make the four bonds with different atoms or the same atoms, so that can complete its octet one, because then its outer valence shell will have the eight electrons, which is fulfilling the octet rule. Now, if we just look at the oxygen, so by the way, these are written, these electronic configurations have written in their normal um, forms when they are ready to make the bonds, right? So now the oxygen, its electronic configuration is this, that it has the two non-bonded electron pairs and the two unpaired electrons. So the maximum bond it can make the two would be through these unpaired electrons to complete its octet one. But it has a surplus resource or the reserves of these electron pair that when there is a needed, it has the ability to donate these electron pairs. So now when the oxygen and carbon, they are ready to make a bond, they are, no, they are ready to establish a friend link. So what they will do is that initially it has a two unpaired electrons. So carbon has a four. So the one unpaired electron, one unpaired from oxygen, one unpaired from the carbon, and one unpaired from the oxygen. So they have established a two double bond, right? So now if you just look at the oxygen, it don't have any unpaired electron, but the carbon do have still the two electron in its outermost shell, which can make the two more bonds to complete the octet one. But this is not the scenario. So now we don't have more oxygen, any of the hydrogen or any of the carbon, which make another bond with the carbon. So now what does it, what it can do is, because carbon can only contribute its this unpaired electron or it's this unpaired electron, and it can only make this one, even then that won't be able to complete its octet one, right? So now the oxygen is that kind of the atom, and it is at a position that is have some of the band balance in form of the two lone pair or non-bonding electrons, and it can do an extra favor that it can make a bond with the carbon to complete its octet, and it also not damaging it because it also has fulfilled its octet one. So let's see how it can do. So this electron pair is sharing by the oxygen to make a link between the carbon and oxygen, and it just asks carbon to keep these electrons with you for some of your emergency time, right? Or you just save this minimum of reserve of your electron pair with yourself. So I can contribute to make a bond so we can have the relationship. Either that could be a business relationship. So in that scenario, these are the two atoms which are making the bond. So this is contributing an extra electron pair to the carbon. So now there are the three bonds with the carbon and oxygen, and both have one um, lone pair of electron. So now if we just count their valence electrons, so carbon has 2, 4, 5, 2, 3, 4, 5, 6, and 7, 8, and oxygen 2, 3, 4, 5, 6, and 7, 8. So they both are now have filled their outermost shell with 8 electrons, and they are fulfilling the octet rule, right? So this is a stable molecule, and this is a right Lewis structure of this carbon monoxide. Now another examples of the coordinate covalent bonds. So from this previous slide, you may notice that these two bonds are basically the covalent bonds, and the third bond, which is just contributing, and this is just only oxygen is responsible for contributing that electron pair. This third bond is basically the coordinate covalent bond. And now we will see an example of the polyatomic molecules. So polyatomic molecules mean which have more than one atoms with that one, right? Or they are separate entities or molecules. And now for establishing good link and to complete their octet, so they are helping each other. So the one of the very good example is the reaction between ammonia and boron trifluoride. So we will see separately what the ammonia looks like and what is the behavior of the boron trifluoride and how they can make a bridge with each other. So if we just look at the nitrogen, so this belongs to the fifth group, right? So there are the 2 in its 1s orbital, and there are the 5 in its outermost shell. So 1 is the electron pair, non-bonding electron pair, and the 3 are the unpaired electrons. So NH3 is the ammonia's molecular formula. So here each unpaired electron has paired with one of the hydrogen. So they have completed, hydrogen has completed its 2 electron outermost. Now there is the hydrogen and there is the hydrogen. So if we count its outermost shell of ammonia, so there is the 2, 4, 6, and 7, 8. So there are the 8 electrons in its outermost shell, right? So this electron pair is there, and it can be donated whenever there is a need to make a bond. So this is called Lewis base. So at the moment, you just know and notice this that this is on the name of the scientist who proposed definition of the base. So according to that scientist, a molecule or an atom which is able to donate an electron pair, and this is rich in electron, this is called Lewis base, right? So you will came to know about these acid and base more in detail in the next videos of the acid and base. I have shared with you the video of to you, and you can see that we can explain that in our next topics, that how these bases and acids definitions are. So right now, the Lewis base is basically something which can donate the electron pair and which is rich in electron. On another side, the Lewis acid is that species, molecule, or group of atoms which can accept the electron pair and they are deficient electron. Obviously, if they are deficient electron, then they are looking for the electron pairs and they are the acceptors. So if you just look at the boron, so boron again, it belongs to the third group, right? And it has in its outermost shell 3 unpaired electrons. So now there are the fluorine, which belong to the seventh group, and they have the 7 electron in their outermost shell. These black electron dots are basically giving you the idea about the electrons of the fluorine, which is from the 7th group, halogen group, and they have the 7 in the outermost shell, and this is the most electronegative element of the periodic table. So now this is pairing with one of this magenta electron of the boron to complete its octet. So fluorine valence shell has completed with 8 electrons. And there was another fluorine which has bonded with this, and this is another one. So this is the BF3, its molecular structure, right? This is a molecule. But if you just look at the boron, so it is still deficient with the electron. Why? And why we said this BF3 is a Lewis acid. So this term Lewis acid and base is right now applying on this molecule as a whole. This is not only on the boron, though the boron in the specific molecule is the only element or the atom which is still deficient in the electron. But overall, this molecule is behaving as a Lewis acid. So BF3, and if you just look at the boron, so it has a 2, 4, and 5, 6. So it is still deficient in the electron pair. And now it has no other source to make the bond and complete its octet one, unless there should be another F. So that should be the BF4. So definitely that will complete its octet one. But right now we have only the 3 fluoride here. So now BF3 is the Lewis acid. NH3 is a Lewis base. So in these scenarios, when these kind of two molecules or the group of atoms approach each other, and they approach in a way that right now nitrogen has a reserve and they have the electron pair which it can donate, not completely, it can donate in a way to establish a covalent bond. But right now this bonding is major contribution or the contribution from the nitrogen, because only nitrogen has this electron pair which can establish a link, right? So this nitrogen is giving this electron pair to the boron and they're sharing with each other, and this is the covalent bond. But this electron pair is only contributing from the one atom, not the other one, boron. So this is called the coordinate covalent bond. And now then there will be the bond. So this will be the NH3 and BF3. So that was a molecule where all of the atoms has completed their octet one. So whenever a molecule which is deficient in the electron, like this BF3, so it can easily make an covalent bond with some of the species which is rich in electron. So that rich in electron species can donate and make a bond with the rich, because obviously when there is a source, there should be a sink. When there is a donor, there should be an acceptor. So in that way, there will be a covalent bond. And one more important thing is that this covalent bond is coordinate covalent bond is equally strong as a covalent bond. So there is no um, um, problem with its strength. So we can't underestimate this bond. And this is very much important when there are the number of molecules and they are again making the very strong foundation and the reason for the coordination chemistry and the coordinate um, covalent complexes and organometallic compounds and the ligands. So all that field or area of the chemistry is basically established on the foundation of the coordination chemistry and the coordinate covalent bonds. So now the next is, I just want to clear your concept in a more daily life example. So as we discussed the ionic bond, so the best example is the parents and the kids. Your parents are giving their best and they are on a donor side and they're completely sharing everything with the kids to raise them, to groom them, to educate them, to feed them. So we are only on the accepting side and the total sharing or the complete transference, basically, not the sharing. So the complete transference is conducted through our parents. So parent and I, the kids, are the example of ionic bond. Then the next is where there is a mutual sharing. So the equal sharing is needed for maintaining and to run that relationship for a longer time. So that's a friends, and this is a kind of covalent bond. Now the next is that if there's an industry, you have skill, but obviously the industry can't establish without the funding. So we don't have anything in terms of the money. So we are relying on the bank. So bank is basically at the stage that they are not looking forward to us. So basically industry is looking for financing to the bank. So bank has a reserve that they can donate to the industry. And this whole finances is contributing from the bank. So this is a kind of coordination covalent bond or coordinate covalent bond or the dative covalent bond. Now, at the end, I have some practice questions for you. So you have to draw a compound, or a compound means, so AlCl3 is a compound. So basically, you have to draw its Lewis structure of AlCl3. The second part is you have to tell that from this molecule, which atom is electron deficient or which electron atom is electron rich. So you have to decide either that AlCl3 molecule, does it has an atom which is electron deficient or does it has an element which is the electron rich. So how many of these have already fulfilled their octet rule? The third part is, does it resemble ammonia, NH3 or BF3 for coordinate bonding corrected? So I have discussed with you in detail the example of ammonia and BF3. So one is the Lewis acid and one is the Lewis base. So you have to decide, keeping that reference, and have to match that for ElCl3 resemble to BF3 or NH3. So you can submit, you can comment on the video lectures. So I'll let you know that either your answer is right or wrong. So you can send your queries anytime. So thank you so much. Have a good day.